Hello all, welcome to the video. In this video we'll show that the current flowing through the capacitor is displacement current. For this we have taken an example here. We have a parallel plate capacitor with area of the plate is equal to 2 meter square and distance between the plates is zero point 0.1 meter. And for this capacitor we have applied a voltage of 20 cos 10 cube t. That is, voltage is not constant, it is dependent on time. And before going further, I'd recommend you to read what is Ampere's law and what is the inconsistency with Ampere's law, inconsistency with Ampere's law and Maxwell equations. Maxwell equations. There are many videos on these topics, so please go through. I'll write a final equation here and I'll prove that the current of the capacitor is actually displacement current. Okay. So in the given example, we have considered a parallel plate capacitor with area 2 meter square and distance between the parallel plates is 0.1 meter, and we have applied a voltage of 20 cos 10 cube t. So let's find the current through the capacitor in a usual fashion. So we have I is equal to C dV by dt, where C is equal to epsilon naught A by B. Epsilon R is equal to 1 because it is a air filled capacitor. And we have epsilon naught is 2 meters and this is zero point 0.1. So we have got 20 epsilon. This is the capacitance in farad. Okay. So substituting this, we have I is equal to 20 epsilon, and we need to differentiate this 20 cos 10 cube t. So this is nothing but 20 400 epsilon, and derivative of cos is minus sign in cube t into 10 cube. So this is nothing but minus 4 into 10 raised to 5. This is a minus sign, okay. Minus 4 into 10 raised to 5 epsilon naught sine 10 cube t. 10 cube t ampere. So this is the current through the capacitor. We need to prove that this is the displacement current. Okay. So let's go ahead and prove this ampere. So some of you might have read about Ampere's law. So Ampere's law, I'll straight away define it in a differential form. So this is the Ampere's law. So what was the inconsistency involved with Ampere's law is, if we apply divergence to the curl of this vector, then we know that the divergence of the curl of the vector is always 0. So we will get del dot J is equal to 0. That is, the divergence of conduction current density is 0. So what does that mean is, in any circuit, the current which flows into the region is exactly the same which flows out of the region. That is, if we have a circuit, say we have a sine voltage here and we have a resistor, so the divergence at this point is 0 according to Ampere's law. That is, the current which flows into this region is same as the current flows which out of this region. So which is true in case of a resistive circuit, but the same case is not true when it comes to capacitive circuit. As we all know that the current doesn't flow through the capacitor plates. Yes, actual electron flow will not happen. There is another mechanism which is involved. The electrons will flow in this fashion, that is across the plates. Also the electrons may come in this way, but the electrons will not flow through the capacitor. So there was this inconsistency involved with Ampere's law. So the like there is a detailed explanation about what is that inconsistency. So I suggest please go through another video. Here I'd like to give a final equation of Ampere's law with modification. So this was the initial. So what Maxwell, he added another term. Okay, as we all know, D is equal to epsilon E. Okay, so if for you, those who have studied about Gauss law are familiar with what is the term called D. So the D is called electric displacement density. Okay, so for capacitive circuits, this conduction current density is zero. Why? Because nothing flows, no electrons flow through this path because it is just an open circuit. So we'll make it as zero. Okay, so inside a capacitor, del cross H is equal to del D by del T. So this is nothing but JD. So in order to find the current inside the capacitor, it is called displacement current, and the current which flows in the other part is called conduction current because actual electrons are flowing. Here the current is due to rate of change of electric field. Okay, so that's what Maxwell derived in his famous Maxwell equations. So now to proceed further, we need current here. So ID is equal to JD into A. So what is JD? That is del D by del T. Here we are considering just epsilon naught because this is a air-free capacitor, and we need to find del D, right? So first we'll find del D by del T. This is nothing but delta E by delta T. Okay, so we are finding displacement current density, that is del D by del P. I say this is equal to del E by del P, where E is equal to electric field which is inside the capacitor. This is defined in this way. Electricity is voltage per meter, and so the voltage was 20 cos NQ by T upon 0.1 meter. So this is nothing but minus 200 cos 10 T voltage per meter. Okay, so what we have now, JD is equal to, we have minus 200 epsilon naught del by del T of cos 10 cube T. So this is nothing but minus 200 epsilon. This is the differentiation of this cos is minus sine 10 cube T into 10 cube. Okay, this is nothing but 2 into 10 raised to 5 epsilon naught sine 10 cube T. This is JD, that is displacement current density. But we are not interested in displacement current density, we are interested in actual current, that is actual displacement current. So this is the displacement current density inside the capacitor. We are interested in electric current, that is I. This we note it as denote it as ID, that is displacement current. So that is nothing but JD into A. A is area, because The SI unit of this is ampere per meter square. So if we multiply by area, we'll just get ampere. That's the simple math involved behind this. So the area is 2 meter square. We get, if you multiply that, 2 into 10 raised to 5 epsilon naught sine 10 cube t into 2. This is nothing but 4 into 10 raised to 5 epsilon naught sine 10 cube t. Okay, this is ID, and the I which we found in the usual fashion was minus 4 into 10 raised to 5 epsilon naught 9 10 cube 10 cube t ampere. Both are in ampere. So just there is a difference in sign because here we are giving the current from external circuit, that is the internal current. So there is a difference in sign because we are viewing from different angle, but the magnitude of the current remains same. So thus the current through the capacitor is displacement current. Okay. For any doubts, please post it in comment box. I will try to make another video to address any doubts. Okay. So that's all from this video. Thanks for watching.